Hello, everybody. My name is Jeff. I'm here with Alias InfoSec, and we are going to talk about some async intelligence gathering with Python. I hope everybody can see my screen. I'll go ahead and proceed. So, little introduction about me and my team. Like I said, I work for Alias. I'm a security engineer here. I do have two certifications. One is a network security certification. The other is a digital forensics, both from SANS. I have my GitHub listed here on this page. I would advise checking that out. It has all the code samples for what we're about to be going over here. Um, I'm soon to be a dad to a baby boy named Callum, so I'm really excited about that. Um, so I've left some line numbers in the examples that I'm going over for if anybody has any questions about that. And the first half is going to cover mainly the Async functionality, and the last half is going to be more generic Python for anybody that has a short attention span and just kind of wants to pick and choose. But a little bit about us. Like I said, we do cybersecurity assessments, penetration testing, social engineering, security awareness training, incident response, digital forensics. There's our website. I'd advise you to check it out. We have a lot of services. So let's talk about why are we going to use Python. So Python is a great language for anybody to get started with. It is open source. So what that means is you can download a copy without having to buy it. So Visual Studio, the professional version for Microsoft, you would have to, if you're doing C# or C programming, you have to pay for that software and that IDE. Python, you don't. It's open source. Another thing is automatic memory management. So what this means is automatic memory management says when you're defining a variable, you don't have to explicitly set its type. So I don't have to say, here's a string or an integer. I can just say, here's a variable and assign it whatever value. And so that's what dynamically typed means. And it's very helpful whenever you want to scaffold or build programs quickly for testing. Another advantage is extensible third-party packages. pip is the Python package manager. We'll be going over that a little bit today. But essentially, if you've used NPM, or there's even one for Visual Studio Code, VC package. But if you used any package managers, these are really helpful. And that's how you get these third-party packages aside from your standard library installed. And finally, the most important one for me is human readable syntax. So Python does not use semicolons or brackets. It operates on indentation, as well as it has some pretty good logical or conditional operators like the word not or the word is. So I can say if Jeff is not true, or I can say if Jeff does not have whatever string in my name, you can do that. And so here's an example of interactive mode in Python. So this is going to be where you're going to be able to experiment with different code or different statements of code and be able to kind of play around in a sandbox type environment without having to save that file and without having to run it through an interpreter. So because this is a live interpreter in essence, so it's really nice to be able to play around. What you see up here is I'm importing a requests library, or library package, whatever you want to call it. I'm making a GET request to our website, capturing that response. And then once I've captured that response, I can look for different properties associated with it. So the status code for the HTTP request is 200. That makes sense. I can look for a string like cybersecurity in the text of the response. And so you see it's true. That is on our website, that word. And I can even look for different headers, like the content type. So you can see that it's very dynamic and a very easy way to experiment with code without having to save files or use an editor. So I really enjoyed using interactive mode, especially whenever I'm debugging. So the title of this talk is Async Intelligence Gathering with Python. And that's super important because of the speed advantages provided by asynchronous processing. So in this example up here, in this graphic, what you see is an example of synchronous versus asynchronous requests. So in a synchronous request, which is typically how most web applications have worked, is a client will make a request to the server. The server takes its time to generate a response, and the client waits for it. After the client gets a server response, it then moves on with its next request. What you'll see on asynchronous side is the client does make a request, the server starts processing it, but then the client keeps making additional requests and telling the server where to provide its response. And so what this does is it doesn't block. That's what it's called, synchronous. It's called blocking whenever you have to wait for one request to complete. Asynchronous does not block. So what that does is it provides a significant time advantage whenever we're parsing and making requests for websites. So in this talk, the biggest thing is how can we leverage already existing tools or asynchronous technology to gather intelligence. So a good example as well of the speed advantages are synchronous requests made, say, a handful of servers. If you have server latencies, say one server takes 20 minutes to respond out of all the 100, well, you're going to have whatever it takes for those other ones plus 20 minutes instead of just moving past it and waiting for it to respond. So it's very advantageous to use asynchronous coding. So let's look at two big tools or two major tools that people use in port scanning. So a lot of the intelligence gathering that we do on different organizations that hire us is scanning for ports. That's the first step in general whenever we're doing an actual infrastructure or web assessment. But basically, everybody here has or should have used Nmap. If you haven't, please do so. It's ultra important. And Mascan, some may be less familiar with Mascan, but essentially, Nmap does your synchronous port scanning. Mascan does it asynchronously. So the only disadvantage of the speed increase with Mascan is that your accuracy suffers. So while Nmap may be slow and have timing differences, which Mascan does too, it's going to be a lot more accurate because it has more tests and it's more thorough. Whereas Mascan, it's kind of like a machine gun blast to the whole internet, so it can be inaccurate at times. But nothing should be set in stone, as in you should always double check your results with multiple tools. But both have a similar syntax, and both have the option to output in greppable format, which is going to be important for us later. So here's a simple Nmap scan. I'm doing port knocking, and I'm just looking for common web ports. I picked a random subnet in Oklahoma City that looks like a Cox business subnet. But you see here, it took 2 minutes to scan 256 hosts for those 4 ports. So let's take a look here at Mascan. The same exact configuration, 26 seconds versus 2 minutes. And that was just with the /24 CIDR range. So you can see the speed advantages on just that tiny range are very evident. In fact, they are 128% faster. So 128% faster on just the 24 subnet. You can imagine if you're doing a /16 or a 12 or even an 8, you're going to be saving a lot of time in finding these ports that are open. So let's take a look at some of the packages that are used commonly in web development, web scraping, and for the purposes of security, obviously open source intelligence gathering or just intelligence gathering. So these are kind of the bread and butter of the Python libraries, that I use for myself. And requests, it'll let you do HTTP requests of multiple types. Beautiful Soup will let you parse HTML text and turn it into objects that you can search. And Selenium is kind of like requests, but it interfaces more directly with the browser through APIs, and it has some pretty powerful functionality. You will see examples of all of these packages being utilized on my GitHub repo. Specifically, there is a Shodan scraper that I wrote, a Census scraper, and a Cisco Talos scraper. Hello, Cisco. And so basically, those scrapers, they're very basic, but they find elements on the page that we would use and say, grab the ports from Shodan, or I grab a reputation from Cisco, or from Census, I grab their banners, because there may be multiple sources that I need to hit. But essentially, these are the packages that we're going to be using to pull data from those websites for our purposes. So again, Requests, it does HTTP requests. You can set custom headers, cookies, post parameters. It's pretty powerful. It also has support for sessions, so you can carry on session data. So it's a little bit more powerful than just say a basic raw curl request, which wouldn't be able to carry those sessions. So what you'll see here is I start by importing the request module or library or package, whatever you want to call it. I set a request or a post request to a URL, and the data is my name is Jeff is true in a JSON dictionary or a Python dictionary, excuse me. So what you'll see down here in the bottom is in the white section is Questbin. It's a good tool. I'll go over it here in a little bit, but you'll see the results from Questbin show that with just 3 lines of code, I've been able to make a post request HTTP to a endpoint, and I can see that result. So it's really cool to be able to make that stuff very quick, make those requests really quick. So here's Questbin. This is what the kind of endpoint tester that I like to use. It's a great place to post data. It provides easy to use snippets for multiple languages, as you see down there. I wouldn't use it for storing classified or sensitive data. The dashboard URL to view your results can easily be derived from the post URL. So don't do anything too nefarious out there on Questbin. Use your own endpoint. So Selenium, like I said, it's a great package for operating the browser directly. It has support for Chrome, Firefox, Safari, Internet Explorer. It interacts with JavaScript. So in request package or curl, you could not say make a HTTP request and then execute JavaScript like a button press. That wasn't a HTML button. You couldn't do that without Selenium, but now with Selenium you can interact with JavaScript. So it's really useful to be able to just find stuff and combining that with Python's human readable syntax, it just makes it all better. So what you'll see here is the top line. I start a Chrome WebDriver, and I go to yahoo.com. So this is going to be in my, I forget what I labeled it on the repo, but essentially it'll search Google, Bing, and Yahoo, and it looks for words or terms inside of search results. So what you'll see here is, like I said, I make a request to Yahoo, and I go through each letter in my request. So if I have, say, Jeff, what I'm doing right here is I'm hitting the letter J on a search input field, sleeping randomly between 0.1 and 0.8 seconds. Then I'm going to the next letter, E, putting that in, waiting randomly 0.1 to 0.8 seconds. And so what you'll start to see is, and if you run the code samples, it starts to look like someone kind of pecking on a keyboard. And this will avoid, this along with loading the browser directly, will avoid getting captured by Google. I hope they don't change this, but if they do, we'll have to figure out a way around it. So it does require downloading some supporting binaries, only like 1 or 2, depending on what browser you're using. But essentially, it's just an executable that you have to have in the same environment that your Python's running from. So here's Beautiful Soup, that package. I wrote a scraper for the Oklahoma Secretary of State. They used just incrementing ID numbers. They weren't randomized, so it made it very easy. So I basically on here define a data URL. And then if the status code is 200, I look for a div. Let me get this laser pointer out here. So what you see right here is I look for a div with an ID of print div. Once I've found that table, then I look for all H3 elements in that table, get the text from it, and strip off any remaining characters. And so that gives me the company name from the Oklahoma Secretary of State website. So obviously I pulled more data, but you can see the ease at which we can identify elements of HTML on a page and pull it, especially with Python. So another useful package and very powerful is regular expressions. I use these often in our work. A lot of times we are looking through a sea of data to try to find the most important bits, and that can become very difficult without having some pattern matching. So a regular expression is a sequence of characters that define a search pattern. So what that simply means is, here's what I'm looking for, what it looks like. So you see on this top line, we import RE. You'll see that that's kind of standard. You import your package that you're going to be working with. I'm defining a string. It's dynamically typed. I don't have to say this string is a string. I can just say string. I should probably be a little bit more exact with that labeling, but whatever. Zip code. So I'm telling it that the zip code that I want, if they look in this string for any number 0 through 9, but it has to be 5, the only thing I can get is a zip code. So what you can see here is zip code. When I'm looking for the grouping from the matches, I get 73112 out of our whole string. So this is a very basic example of regular expressions. They're very powerful, and they can get it looks like hundreds of characters long if you've seen some big ones. So down here's another example. Say we have text within HTML text, and we found somebody that is using a comment to hold a password for an input field. So say you're scanning thousands of pages and you're looking through all of them looking for comments because you want to find stuff in comments. So what we can do is, say we're looking for a hex value. I can say the hex value I'm looking for is 0 through 9, A through F capital. It has to be a minimum of 16 characters. It could be lower, but I just chose that for the example of this demonstration. So what you can see here is, if I'm running this on a whole HTML page, I've just pulled a password from a comment, and I don't have to look in that source code. The searching will do that. So here's another great example. It's called Pythex. And so what Pythex does is allows you to test regular expressions for Python. So what you'll see here is I put in our test, or our address as a test string. And up at the top, I basically said I need something that's 0 through 9, any characters that's in parentheses. And so what you'll see here is we're getting that match for that phone number. I'm not going to get too much into that regular expression explaining it, but you can look at it a little bit later if you would like. There should be some of those in the code examples. So let's talk about putting all this stuff together now. So in our work, a lot of times we'll be given a domain name. So we get, say, aliasinfosec.com, and then a client says, we need you to pen test us, and we need it to be black box. We need you to cover as much ground as a hacker would. And so being the hackers that we are, we can use all these open source tools, but if we have high volume of data we need to research, it becomes really difficult to load up the browser, or load a tab, type something in, browse for it, copy and paste, and nobody has time for that. So especially if you're doing thousands of pages or domains or IP addresses. So like I said, we typically start with DNS dumpster. We'll take a domain name and we'll put it in there. And I like to pull all these A records out, or just all these records, DNS records. So what we'll see is the typical or page from DNS dumpster, IP addresses, etc. So let's take a look inside of that source code. So if you're not familiar with the inspector mode on Chrome or Firefox, you should be. Take a look at that. And so what I'll show you here is inside of the inspector mode. So those results from DNS dumpster are all parsed, or are all printed out into a table. So you'll see up here in this source code I've highlighted, here's one of these table rows, tr, td, table data. So inside of table data, we have a link, we have forms, but I have identified through the research that here's an input that's hidden. We got a middleware token, so I'm probably gonna have to use that. And then I've also got an input that's hidden with, look, the value of one of these IP addresses. And it has a name attached to it, SynScan. So none of these other inputs that I'm looking for have a name of SynScan. And I'm sure that there's only one CSRF token applied to the whole site. So now that we kind of know how there is the structure of these results, how they come back, we know a unique identifier for the data we want. Let's go ahead and look at how we can get this stuff pulled together and get data out of it for an automated kind of console output. So here, what we start with is, like I said, request has support for sessions. We start a session. We get the URL, which is going to be dnsdumpster.com, and we instantiate Beautiful Soup, which is our HTML parser. And then we find immediately our CSRF token. So basically, when you first go to the root of your page, of the web page, it'll provide a token, usually kept in the session or a cookie, or on the page is this example. So what you'll see is we want to load the root URL, and we want to grab that middleware token. So then what you see right here is I form data that says, here's the middleware token, and here's the target IP I've passed through a command line argument. So I'm basically just getting myself ready to make the actual request. So down here, we see I'm making a post request instead of a GET request. I'm making a post request to that same URL and getting it with the data up here. So I'm posting to DNS dumpster, posting to DNS dumpster. I'm posting, excuse me, the CSRF token as well as a target IP. And what that does is CSRF, cross-site request forgery. It prevents it so that people can't make requests like this on your site. It's not a fix-all as we see. So that's one kind of security control that people put around it, but it's fairly easy to pull that out, at least for this example. So once I've made that request and gotten a page like anybody would on a browser, I use Beautiful Soup to parse that. And I'm looking for all table rows. So I will parse through each row in the identified table rows, looking for the SYN-SCAN name that belongs to an input tag. And if I do find that, I append that list, or I append that to a list that I'm storing in memory. So down here, if I do have an IP list stored in memory, show me how many of those I collected, from what IP address I specified, and then I'm going to open up a text file with the name of the IP or name of the domain I specified, -IPs, and I'm going to write all of those IPs to that text file. So as you can see, it can be fairly easy to reverse engineer some of these sites. It's very fun, not easy, but it's fun. So let's take a look at that. So I ran the IP scrape. Like I said, these are on my repo as well. I ran the DNS dumpster IP scraper on our own website. It tells me we collected 4 IP addresses. So I'm using type. I'm used to using cat because I'm a Linux guy, but Windows, you have to have type unless you got Sigma installed. But still, type alias infosec IPs. So now I get a list of IPs. So I could take this list of IPs now, and I could plug that into Nmap and define -il, say, here's a list of IPs. And that obviously can be automated as well. But you can see we take a free resource, and it's very passive too. So we're not querying any kind of server. We're not doing port scans. This is all passive stuff from a third-party website. So we've essentially been able to, we can do kind of a basic pen test without even touching your site based on the open source, or at least have a good analysis of vulnerabilities. So taking it a step further here, so we do have a list of IPs, and that's cool. But what if I want to see what those host names are? Because IPs are nondescript. But if I have a host name that's a name server, I don't really, unless it's I don't really want to go after a name server. I'm looking for more mail or web servers, and at least what we do for web app. So what you'll see here is I do look for the SYN-SCAN name, and I've modified it that if there is a IP from SYN-SCAN, I basically use a socket command to get host by address for that IP address. And basically what this does is it gets the host name, and it ties that as well. So the output can be modified very easy with a few basic packages to have something that's pretty cool, to be able to just run it from the command line, and in a couple seconds get back all these results without having to and to be able to loop that. So it's very advantageous, and I really like DNS Dumpster as a resource. So let's take a look now at a demonstration of one of these tools. Like I said, this is on the repo. This is the async gathering tool. And so sorry, not async gathering tool. This is async, but what it does is it lets you define a port, and it's for web, and then it pulls out the first 200 bytes or so of the HTML body, or 200 characters. And so what that allows me to do is kind of see a glimpse of what's inside the source code for just a multitude of IP addresses or web properties. So I incorporated as well CIDR range and mass scan. So let me go and show you how we pass a CIDR range and a port to the tool. It uses mass scan to kick off the scan in greppable format. It parses that greppable result And for each one of those grepl results, it makes an asynchronous request to all the URLs. And it gets the first 200 bytes of the HTML body. It sounds kind of convoluted, but let's go ahead and demonstrate it so you can see. Okay, so I'm running the tool. See Masscan, it's kicking butt very fast. It's already found 64 hosts in that 24/24 CIDR range. And so what you'll see now is it's building the list, but as soon as it starts making those async requests, they start pouring in fast. And so that is a ton of that's a ton of speed compared to making all these requests through any other kind of synchronous or any other kind of tool. Eyewitness does do a very good job at kind of similar stuff, but I like to customize everything and automate it as well as I can, especially in just information gathering. So 64 hits we found from 256 hosts in about 20 seconds. So that's really fast to be able to take a 24 CIDR range and in 20 seconds be able to look at all the content on all the matches. In this demonstration right here, what you'll see is this is all a Google owned range. So basically the start of this body is all going to be the same. So it's all going to be Google based, probably their search page. But if you were to use this on any other CIDR range, it would pull a lot more unique and variable results. It'd be a lot more dynamic looking than just the same HTML. So here's another demonstration of the tool. Like I said, uses Selenium to search Google, Yahoo, and Bing. So what this does is it was created to find, like I said, a specific search term, and it's useful to see if I search for information security. I want to look in the top 10 results of Google, and I may be looking for text data. I may be looking for, say, a phrase in the top 10 results for the word information security and holding that URL for later. So it's very helpful to be able to look through these search results, kind of like the same way that we did in the previous tool through the HTML results. So it uses Selenium WebDriver, Beautiful Soup, requests, and regular expressions. Chrome driver started. We browsed to Google. The search field's identified, and we emulated user typing on the keyboard. So that delay that I spoke of, where it's anywhere between 0.1 and 0.8 seconds between key presses, that essentially makes it look more human. Then I go down to the bottom and I click next until I have a limit defined. So I only want, say, the first 10 pages. Then once I have a list of all these URLs that match the word information security, I load the HTML in Beautiful Soup, and then I look for elements that match that and print out that element. So an advantage of Beautiful Soup is if I search Google for information security, I find a link for alias infosec, and then I look inside of that, and then what I'm doing is I'm looking for the different elements inside there, and say we've got a paragraph tag that has the term I'm looking for. The cool thing about Beautiful Soup is it pulls all the text within that tag itself. So it may match on the word cybersecurity or the phrase cybersecurity, but if it's a whole paragraph of text about cybersecurity, that's what Beautiful Soup will pull in and display. So it's really fun to see what's out there and see it kind of quick. And it'd be great for historical data collection. And I even used it on my name, just did cybersecurity Oklahoma and looked for my name, Jeff Bowie. And I found a URL that I didn't even know that I was on. So it was pretty trippy. Anyways, let's take a look at this tool. So here it's popping open Google, and there's that delay that looks kind of human. See? And then we hit next multiple times. We're picking up all these URLs. So we're recording every URL. And for this demonstration, I just did Google. I didn't include the other search engines. Those are just commented out in the code. And so what you'll see here is I'm looking for the word ransomware in the links for cybersecurity. And I am finding a bunch of results. So this is synchronous. This is not async. That's why it's taking its time, kind of. So the blocking is what's slowing this down versus the other tool just spit out results as fast as almost we could see them. So what you'll see here, again, is, like I said, you have these different basically paragraph tags or whatever the element is, and it's finding that word ransomware, and it's pulling all of those URLs plus the first plus the text that was in the element. So it's very cool to be able to search quickly and then use these tools. My tool will probably get blocked by Google or something like that, or they'll just figure some way out to prevent it. But for now, it's a great way to be able to take these tools or packages that are out there and take free resources and really leverage them to be able to be able to get your goal. So speaking of leverage, here's a kind of example of how I've leveraged tools. So like I said, with our previous example, we're using Mascan. So the biggest line I guess I want to point out is if there is a CIDR range defined, what you see here is we're using Python. It's a standard built-in function, but subprocess. So subprocess is basically like a popen, not popen. Subprocess is basically will run a binary and it will monitor your standard out, standard error, and allow you to pass arguments, and then it will let you parse that. So this OJ from Mascan that I have flagged, it's output in JSON format. And so you see down here, found hosts. I load the JSON format. I remove the byte encoding. I can do that through a different mechanism, but I'll fix that. And I'm just basically replacing dummy text and looping through that. So I say all this to say you can run different binaries on your local system, do it blindly so you're not spitting out output, and then you can record those results and parse through those within Python. So it becomes very powerful. Something like a ping, you could even record the results from Python and then make intelligent decisions based on if pings have a certain delay between them or if you have no response. So it's very powerful to be able to leverage existing binaries on the system, and then with open source tools, it's you can do a lot. Okay, so one of the hardest parts of gathering data is avoiding detection. It's really hard to be sneaky, especially with the technology. It's always a cat and mouse game. I remember I tried to write a scraper for not a scraper necessarily, but something for eBay, and they actually use some type of technology. I forget what the name is, but it makes it really hard to do. So I just gave up. But that avoiding detection is very difficult for a lot of reasons. Let's take a look here though at some source code and how that's accomplished kind of. One of the ways I like to avoid detection is I like to roll my user agents as well as my source IP. So what you'll see here is I'm defining a list of user agents. I would suggest if you're doing this to look at the latest user agents and always use those. A lot of people or a lot of websites won't display pages correctly if the user agent's not set. So it's important to have a user agent set in most HTTP requests. Then I define a proxy list down here. So you could use something like proxy chains to cycle proxies per request. But right here is a simple, I can define a proxy. It's only one, and then I define a URL. So think about it like this. If I'm looping through consistently, so I'm on an eternal or infinite loop. I'm making a random choice of a user agent, a random choice of a proxy, making that request. So essentially what I could do is take the same URL and loop through multiple pages, but each page I request, I'm doing it with a different user agent, a different IP address, but I get all the results at my end. So what we should be able to see is it'll help prevent detection, and it will also provide a little bit more coverage because you may have different regional or different data that gets returned on the page based on user agent or region. So one of the ways to kind of display this, I've used, if you haven't used Burp Suite proxy, it's a great proxy, web application proxy for testing. It's a great way to look at what data comes in and out as long as you can route it through. So in this example right here, what you'll see is the code in the previous page I used to cycle a user agent. So I set the proxy to just Burp Suite. I could have multiple proxies in that list, but for our demonstration, I want to set the proxy to Burp Suite, run the code, and then you can see kind of how that user agent changes. So let's go ahead and look at that. So here I've run the code. I'm making multiple requests to our website. And you'll see here, I'm going to stop the requests on the right, or stop the Python script on the right-hand side. Then I'm going to go on the left-hand side, and I'm going to select each of those requests. And so I've highlighted user agent down. Well, I lost my cursor. Anyway, I've highlighted user agent down here where the laser pointer is. So you should be able to see that user agent is changing each time. So it's be able to cycle the user agent, and if we did have multiple proxies in that list, cycle proxy each request. So it should start looking a little or unique to at least a firewall or an IDS system, is the hope. It does work for me, but it's just I have had limited testing exposure. I haven't had testing exposure to every type of device, but on all the engagements we've done, this has worked so far. So let's look at some storage modules here, and kind of talk about how we can use these. I'll show some code examples. CSV, anybody can open it with Excel. They can sort, manage the data, and so CSV is a great way to store this intelligence once we have retrieved it from the internet. So another one is SQL Light. It's another one of my favorites in terms of portability. It's very simple in terms of it doesn't have that many diverse data types like MySQL. You get some very basic like text, integer, etc. And then you have MySQL. So MySQL has authentication, and it needs to be hosted on a device or in the cloud. Versus SQLite and CSV are modular and don't have to have any kind of hosting. They're just file based. So what you'll see here is a little example of SQLite, how I would say how easy it is. I import SQLite up at the top. I create a connection. So this was from the Oklahoma City Secretary of State scraper. I create a connection to the DB file, which is SQLite's extension. I define a query. So I'm basically looking for a file number. And then I get myself a cursor to the connection, and I execute that SQL query on the cursor. Then I fetch all the rows from the cursor, and I'm able to parse through those SQLite data results. So you see 19 lines of code. That's not even 19 lines, but very short line of code to interface and to make select requests, etc. on a SQLite file. So it's 35% faster than reading or writing to individual files on the system. That's according to SQLite.org. I'll have to test that out, but it was pretty sexy stat that I'll have to look into. And of course, like I said, the application file is portable across all systems. So here's a CSV example. That results list, you see OpenCSV. We just write that list of results to a row of CSV. Sorry, let me explain that better. We open up a CSV pointer to the file.